The real reason we only do 10-minute talks is because every time you cover another topic, you want to do it over again. And if it's longer than that, you got so many takes. So couple people have asked, what are the trade-offs in organizing your raw data? Am I going to pick different strategies, and why would I pick them, and what are the advantages, right? Disadvantages. So we're really talking about ingestion and transformation here. And in a way, well, these are the things that feed your decision, right? So we're going to put data somewhere where it's consumable. And the question is, who owns making that data consumable? And are you capable of doing transformations and promotion? Right? So if you can't do transformations and promotions, like you can't take data in one format and you have nobody home to make that data consumable by consumers, then you're probably going to have a problem with any of the approaches. And either consumption will be hard or production will be hard. Producing will be hard, right? So what we're going to assume is that we're going to decouple and create a boundary between systems where the producer's on the hook to create a producer model, create the data, and that goes somewhere. And then somebody is capable of putting that, either normalizing it or denormalizing or doing something else to make that data more consumable. And you can support that. And so the rest of this is based on that assumption. So if we look at the raw zone, which is basically the drop zone, right? I'm going to take data from the producers and I'm going to put it there before I transform it. What are we going to talk about? And there are different ways you can do this based on philosophy. And the question somebody asked was, do I use one giant column? Do I use many columns? Like, what do we do in the landing zone? And remember, what we're going to do is we are going to optimize the ingest for producer consumption to make consumption easy and reliable. And then we're going to optimize the consumer models to make it easy to consume. And then we have to figure out how to transform in the middle. And we can talk about that in another talk. So in my mind, raw data that you land isn't really for consumers. You can consume it. I'm on a project now where we're going to consume it, and it'll be painful. And part of the reason is it's the producer model. And another part of the reason is no one has access, probably because there could be PII in there, private personally identifying information or other secrets, right? And so I have 3 standard patterns that I've seen work the last couple places I've worked. We've done all 3, depending on the company. One is the raw data lands exactly as received, right? And so we just take the data as it exists and we put it down in exactly the same format with no change. And then we just got to figure out how to make the storage work for that. Another one is we take the exact data and we standardize or create a canonical format for all of those. We might take all the flat data and convert it to Parquet. In that case, you actually lose the original data format. So it's possible if you did a Parquet, like a Quark or Parquet translation, you might actually have broken something and you've got no way back to it. So I'm not a huge fan of changing the format. The only other one here is you can tokenize or you could standardize certain fields. So you could be like, all dates are in this date format, all dates are all PII is tokenized. And so you might do that. And so some people will do basically exactly as received, except they'll standardize the dates or they'll tokenize PII. But other places I've worked, we don't know what's in the data in the raw zone. So we just make that zone inaccessible. And I'll talk about that a little bit later. The other thing you got to do is, depending on how you're going to land this data and what type it is, and we'll talk about the different types and why this is mandatory, right, is you got to pick a metadata and data coordination pattern. So you're going to lay this data down and you're going to lay data down about it, right? So it'll be like, I write this document out and I received this document on this date and it came in on this channel at this time, right? And so, and there might be others. You might create a unique identifier for everything you receive. So this is my reception identifier. And if I write that thing out, I need to write the metadata with that reception identifier. So you got to decide a pattern for that. So pick the pattern for how you want to change the data and pick how you're going to coordinate the metadata and data, or at least think about it. So data structures drive differences. And so let's talk a little bit what the different formats are, and we'll get into why they're different. So we have flat data. I worked one place. The only thing we ingested was flat data. Made it super easy. It was stupid, but we did it. And then everything that wasn't flat, we were like, it didn't belong there. And then we had to come up with a whole new way to store everything that wasn't flat. So maybe it was good, but it took a long time for people to come around the fact that we needed to store things that weren't flat, right? And then we have nested. So we could have flat JSON with no nesting. A lot of times that's just a contract thing. We could have binary, which would be like an Avro, and so that makes it difficult Maybe it's not a great consumption format for people, like you can't query against Avro easily in a lot of systems. And then you got JSON and XML, and you got some kind of flat data. It could be, I've seen Parquet where it's flat, and then they put nested JSON in a field, right? So that actually became a nested document. The document came in flat, but the reality is if you're going to query the document, it was a nested document. So another one here, the last one, which I really, it always amazes me when we build something and then later on we're like, man, where are we going to put all the pictures? So in this case, we have images, recordings, and movies. Anything that's binary comes with its own challenge. Typically, you'll store the data and metadata separate for those. So you got to pick an answer for that. So what are the design drivers for this? I think, how big is the data objects going to be? Our individual items can vary widely in size. Is that true? Some of them are pretty relatively stable. Others I've seen, they can go from 1K to 4 megabytes in a single record because it was a document, right? And binaries can be huge. So you got to figure out, there's probably no cap on a binary size. And they may have to be encoded in certain storage. So if you're going to pick certain patterns, do you really want to encode it? Are you going to have native tools that can reach binaries and can search against them? You may need to pick a storage that's supported by the tooling, right? And going back to documents can be super large. Like I said, I had one that was 4 gig. It was like whatever max above the column size, right? The document could be really large because it had a bunch of nested documents. And then we found out one team was putting out documents that include embedded pictures in it, right? And that was a nightmare because it totally changed the size. And then we didn't have we had to just figure out a way to store that in our raw area and then tear that thing apart to put it in a consumable area. And the individual items could vary widely in shape. You'll see this with documents sometimes. If I'm doing, I'm going to pick an insurance policy. Policy might be for one person and their jewelry, or it might be for 20 people in a fleet of vehicles and, a bunch of other stuff, right? And so one of the things I think you got to do, and you got to decide in the raw zone how much you want to do this. You might need to align with consumption tools. So if you're going to do transformations, you might want to set yourself up to make the transformations easier to make the consumable model. And so you got to take into account a little bit like how you're going to read that data and write it either for end user consumption, although we don't worry about that in the raw, or for the transformation tools. So pick your design drivers. All right, so let's walk through. The next 3 slides are really just going to be talking about the 3 data types. So the flat data in the raw zone, the record side is usually understood. I'm going to say there's 2 different. You could have a lake, or you could have, it depends on what kind of data store you're going to do, whether you're going to use something like Snowflake, or you're going to do Azure Data Lake, or you're going to do like AWS Lake Formation. Google's probably got something, but I never use it. And then lake optimized, right? So if it was lake optimized, this would be flat file blob store optimized. You could convert to a well-known flat file. But if you do that, that would break exactly how it's received. And if you do it in Parquet or one of the well-known files, you could actually take into account data sensitivity potentially. But you break that exactly as received. So if you receive broken data, you got to figure out where you're going to put it if you pick a lake optimized format. You could also pick, if you were going to put this in Snowflake or one of the record-oriented storage things like Delta Lake maybe, or Lake Formation, I guess. You can encode the entire message in a single column, so it's exactly as written or as received. And you got to make sure that you got enough space in your column sizes, right? So like if you're in certain data stores, there's going to be a column size limit, or certain tools will have a column field limit, right? I can't have more than 4 gigabytes in a field. And if you do the record-oriented storage, some of these formats will work for flat files or databases. Some of these systems like Snowflake hide the storage. So you could do like record-oriented. If I put the entire message in a single column, this is actually where the question came from. System I'm working on, we actually put the entire record nested JSON in a single column, and we put metadata in the other columns. And that way it looks, we didn't do any transformations on the data, but it fits in our store, right? So that's, you could do it in the data lake the same way, right? You could do a data column with an encoded version of the original, and then you'd have all the metadata columns. It's kind of like the Snowflake example I just said. And then you got to pick, the only thing here is the column data sensitivity, or the data sensitivity you look at is going to be the max of all the elements. So if you look at semi-structured in the raw zone, they can be really loud. a lot large, right? So unlike the record ones, we kind of know what their size are going to be unless they have an embedded field, but that makes them nested. We could do, a lot of times for semi-structured, we might do one document per file. This works really well for large documents. If you're doing lake optimized, you can append documents to partition files, like you can make them an entire nested document be a record, but I've found that that can be difficult to process. And it's just, I don't know. I'm not as big a fan, but you could do that. And then we go back to the storage agnostic semi-structured, same thing we talked about before. You just got to look at the column limits of workplaces where we thought this was going to work, and then somebody sent us one bigger than the column. And then it turned out to get that stuff loaded in the different pipelines, those columns were so big that it didn't make sense, and some of the pipelines broke down. And you know, you can also, the other thing you could do is you could work with the flat, the advantage of the storage agnostic approach where you put it all in one column. Like I said before, these are exactly the same points as before, is it'll work in a data lake and it'll work in Snowflake and other systems. Again, the problem here is because we did it all in one column, this data sensitivity is basically the highest of whatever all the elements are in there. So if there's one PII field in there, the entire record, the entire document has that because you didn't pull it out. So binary, this one, it always amazes me. I worked at a place and they were like, well, we have no place for binary in our lake. We have no place for binary in our database. And it turned out we had major use cases for binaries, right? We had pictures, we had audio recordings from service reps, those kinds of things. So this one, again, I think the lake optimized, there's probably only one approach here. And actually binary, you're not going to reformat. They're going to have to be in producer schema. And my general view is you produce one document per file in the lake and you pair it with metadata that's in a lake table somewhere and you point at it. And you don't embed binary. I worked one place and the lead architect manager thought we should embed, and this might make sense, so I should be careful making fun of it, but that we should do everything in Parquet and all the binaries would go in a column in Parquet. And when the partitions got managed and stuff, it made really weird Parquet files. So another one would be storage agnostic. We talked about it before. Binaries, entire document in a column, that's kind of what we just talked about. I'm not a big fan of that. You might have to be encoded. You might have size limits, but that is an option. We would just treat binary like any other document and put it in there, and that's an option. And the only thing here I would say is we have to assume that all binaries contain sensitive data, and so we need to treat them as PII, and that means any data store they're in is a PII risk, and so you got to figure out. In that case also, a lot of times the metadata isn't PII, so we might separate the metadata from the data, and that would make it where anybody could see the metadata about the binaries, but they wouldn't be able to see the binaries. I hope you all have a great day.